Hey everybody, I'm James. Thanks for the great introduction. I've been meaning to get up here for maybe a decade, so it's really nice to get the invite now, and we have a really good excuse to be hanging out in North Sound talking about cutthroat trout. I work with Wild Salmon Center right now. That's my day job. But most of my career has been with Washington Department of Fish and Wildlife, managing fisheries in Western Washington. So it's kind of a new role for me. But when I worked for the state, myself and my friend Greg Shimmick started this Coastal Cutthroat Coalition that you guys, I think, have seen a little bit about. And now there's a bigger group running around trying to increase the understanding of cutthroat. So that's what we're going to talk about today. My idea initially was to just break right into Samish Bay and like tell everyone about how excited we are about the Samish Bay work. But I felt like since we hadn't been up here before and chatted about cutthroat trout and kind of where we've brought the research, it'd be a nice sort of background on what we've done. The other thing to note is I don't get a lot of chances to sort of share the last 15 years of cutthroat research. And so this is an opportunity for that too. So I picked what I thought were kind of like the sweetest spots of the cutthroat work, stuff you guys I think would be interested in. And so if there's something that you like want to pause on, we can go slow. But if we want to just move through it because it's not something you're interested in, just flag it. So I just put a lot of stuff out here that I think the group will enjoy. I put my name on here, but then a lot of other people, a lot of scientists, a lot of conservationists, volunteer groups, government groups. On the bottom is a banner of like formal organizations that have jumped into the work that I'll share, like the finished, sort of polished work. But this list, just from the Samish Bay project that we're about to kick off, this banner is going to get pretty huge. I can already tell. When we started talking about it, the energy was really high. So there's some people and organizations missing. I can already see that. So let's see how maybe we're paused. There, we'll do that. So here's the outline for the talk. This isn't a super long presentation, but there's some key pieces I really want to make sure we're all on the same page on for cutthroat trout. So I'll do a little introduction. I'm going to talk about red counts and spawn timing because folks in this room I know are helping with the steelhead work on the Skagit and other places. So that'll be kind of nice to sort of link with what we're doing with cutthroat. Age and life history diversity is an important topic for this fish, and we've taken it to kind of a new place. Marine movements, that's the Samish Bay project. And then that'll lead us into this link between shellfish and cutthroat trout and why we're sort of having the conversation together. So first, kind of this, oh, thank you. That's much better. Kind of introduction. So I mentioned I work for Wild Salmon Center. I don't want to like dig too deep into this because it's a little out of scope. The Wild Salmon Center has this really broad scope focused along the entire Pacific Rim. And the main strategy for Wild Salmon Center is to focus on these pristine places on the planet that are holding like kind of these last strongholds of Pacific salmon. And the idea is to lock them up and stop anything bad from happening to them. That's a lot different than coming into places that are heavily degraded and trying to bring them back up to speed with these pristine places. So different strategy. But the reason like why places in Puget Sound matter so much to us is we have lots of partners doing like super important work that we can help sort of fuel, even if it's in the background, not as the lead. But also we're learning things in places like Samish Bay that we can apply to these strongholds. So lots of words there and topics about Wild Salmon Center, but the main idea is we're working in places like Mongolia. Here's the Strait of Juan de Fuca, Puget Sound, and then here we have, sort of the mouth of the Quileute River out on the Olympic Peninsula. These are the strongholds I talked about. This is our Wild Salmon Center map. And there's this really great publication that just came out last year. Our executive director, Guido Rahr, was the lead author. I can link you to this after the presentation if you want, but this is like a super good read. It's a great science paper and talks about why this stronghold concept may be one worth thinking about. But then now if we jump to the Coastal Cutthroat Coalition, folks in this room already understand why we care about cutthroat trout. but not everybody does. That's essentially what this slide is saying is, it's not commercially important. It's not federally listed under ESA. There's a lot of reasons that cutthroat trout get prioritized like way down the list from other species like steelhead and chinook and coho. And some of those reasons are really good, like reasons we should be focusing on other animals. But the bottom bullet there sort of describes why cutthroat trout matter. And we noticed about 15 years ago that if you Google cutthroat trout, not much comes up. It's kind of hard to understand what this animal does just because the work hasn't really caught up with these other sort of, we could argue more important species. So we've made the case that we think these are worth studying and we should maybe collect our group change and try to put together some studies just to get them back up to sort of our level of understanding as these other species. This way, fish managers would have tools at their hands to make sure they protect them. That's the main concept. So the recipe for the Coastal Cutthroat Coalition about 15 years ago.
Slide.
Yeah.
That non-commercial species, you run the risk of taking something in hiding, bringing it forward, and all of a sudden, wow, there's a lot of commercial to be done there. You worry about that we put too much eyes on something that's now hidden and allow commercial entities to all of a sudden show interest in something heretofore was hidden.
Yeah, great point. So one reason, and each one of these bullets are worth us digging into, like sort of in depth, but one reason that they're not a commercially important species is their body size, their biology, where they occupy in the marine environment, super near shore, shallow environments. And also, there's not a market for a fish that's super abundant, takes hours to catch, and would be heavily depleted after a couple of years of commercial fishing. So the commercial industry, 120 years ago, as they were developing canning and commercial fishing operations, identified cutthroat as like kind of probably not one that we could make a bunch of cash off of. But it is a little misleading because we do know there's guide fisheries. There are commercial entities benefiting from cutthroat trout. So I think you make a good point. But in terms of Chinook, chum, pink sockeye, they just fall under the radar. And the fish that get harvested and sold get studied pretty well. So that's kind of the point there. But it's a good point. So like I was saying, if you're a scientist and you're like, my goal in my career is to get cutthroat caught up, it's a pretty ambitious goal. And we thought that maybe the best way to do it would take these tools that we already know, they're well developed for these other animals, and just apply them to cutthroat trout. Let's not like reinvent the wheel. Let's learn lessons from Chinook and coho and these other species. So we have these tools. I'm going to use this laser pointer. Maybe. Can you guys sort of see that green dot? So we have things like counting parasites, sea lice that you see on salmon, using scales to estimate age and growth, tissue samples. These are, genetic analysis, lots of things we can learn there that I'll talk about. Just measuring and weighing fish. 10 years ago, you could measure and weigh 10 cutthroat trout caught in the sea and publish it. I mean, this information was not readily available for cutthroat trout. So we've sort of moved the dial that way, but just basic information. And then we'll talk a little bit about more complex tagging operations, as we've sort of become more sophisticated in how we study cutthroat. But really just basic tools here. And this is a cutthroat trout, by the way. If folks haven't seen a lot of these, this is like what we would say is maybe average size, about a 10-inch cutthroat trout caught in the marine water. And these are all these ectoparasites we're talking about. And then the other thing that's gotten us here is just collaboration. With the Coastal Cutthroat Coalition, everybody is invited. That's been kind of a major point. We've said, hey, no matter which fly shop you get your flies from, no matter which fly club you're a part of, what your favorite beer is, like everybody gets to join in this effort. And that's been really important because it's made folks feel like, even though I don't really love hanging out with this person, it's about the fish. And we tried to keep it that way. It's not about the scientist. It's not about any one of us like excited. It's about the fish. And all these folks from different sort of walks of life and organizations and nonprofits have jumped in and thrown in small amounts that have kind of amounted to a lot of science. And for us, this is the main currency. Our number one goal is science. Just get them caught up. And we're really proud of, this isn't all of them, but it's kind of this pile of scientific literature that this community has kind of brought together. And a lot of this is crazy basic science for a fish species in 2026. But all these are available on the website for free. So you can like pull these PDFs and just become a cutthroat expert or closer to it pretty quick now. So that was a little background, kind of where we've come from. This red count work, I think, has kind of been our bread and butter, like the foundation of the Cutthroat Coalition, because counting reds is free if you have really good people. They're young. He was walking some steelhead streams, decided he wanted to see what happens, kind of later in the season, like May and June. And in South Puget Sound, he started counting these like small little steelhead reds. And he learned pretty quick that those were in fact not steelhead. They were basketball-sized cutthroat reds. And it was in an area where he found most of these was in areas where steelhead were extirpated. So he was able to zero in on like, what does a cutthroat red look like? And from his early work that's now published, we were able to build this sort of army of people walking and counting reds. And these are time series, just beta, just number of red counts in a stream. And what's cool about this is Skookum, McLean, and Kennedy. And here you can see these 3 streams in South Puget Sound. What's really cool about these 3 streams, you can see these highs and lows, really basic data. And in years where we think there's like a panic situation, 13 reds in a stream, maybe that's 30 fish max. We can, call our local government agency and say, hey, you guys should probably hit the panic button in McLean Creek because something's going on there. And then in years where it's, really high counts, we can maybe say, hey, did a culvert get replaced? Is there some kind of improvement that happened in the system? Maybe regulation went from harvest to catch and release. And we can demonstrate that like, hey, we might have just turned a dial here that matters. And in this case, we've done that. And we're slowly seeing these kind of ramp up of these red counts. But the other thing, maybe the most important thing about these red counts, what I think, is we can see when cutthroats spawn. And it was crazy in like 2013, if you asked like cutthroat experts when they spawn, you got all kinds of different answers. And to have a wild native salmonid in Washington State that we don't totally know when it spawns seemed just out of control. So we solved that puzzle. And when I say we, it is like lots of people walking streams. So this graph's a little bit tough to get your mind around, but on the x-axis here, this is just time. And each one of these lines is a different year. It's the same data I just showed, but now you're looking at these red counts kind of build through the year up to 100%. And what you can see is they reach 100% at different times. Sometimes it's like in April, sometimes it's in June. Each year looks a little different, but this figure helps for me, if I put this line at 50%. So this is the peak of spawning, when 50% of the reds were counted. And what you can see is some years, 50% is in February, and in some years we're like in late April when half of the reds are being counted. So I would argue, no other salmonid on the globe where their peak red counts shift by 2 or 3 months from year to year. I mean, we talk about life history diversity. Those that know a little bit about steelhead are thinking like, this kind of sounds like steelhead, but maybe on steroids. Maybe steelhead 200 years ago, before we kind of contracted the spawn timing. So super diverse. And we're making the case that if you're a fish manager thinking about cutthroat, you might need to like sort of rewrite the book on how you do it. It's not like chum where it's like a 3-week window you can count chum. And so
that's just South Sound though.
Yep.
I don't know about the Skagit or North Sound when they spawned.
Yeah, so great point. Everything you see today, all of the cutthroat work we've done is really place-based, right? Like no one's gone because we're talking like we're sort of go back 100 years and think about Chinook salmon. So these are all data Bill Young collected from one stream. This is the longest time series we have for cutthroat reds. But what we've learned is this spawn timing does shift from river to river. There's some places where we know now we've documented November spawning, which just doesn't even exist on this graph. And there's other places where you've got really robust steelhead populations where cutthroat are shoved all the way to the back end of the summer. So super diverse, probably filling in whatever gap exists. Without going into detail, there's also a great paper by John McMillan that's titled Unusual Spawn Timing of Cutthroat Trout. And that's in the LWA that was in like October. So really, all over the place is the point here. and again, all these things you can like read about online, like the sort of formal publication. So that's kind of the background about red counts and spawn timing. Now we're going to look at age of history diversity. This is like, whoa. One of those like I kind of put on the wall because it's just so pretty. I really like to look at it. So I forced it into this talk, but it's also really important. So what we're looking at here, these are age data from cutthroat trout across 4 different regions. And then here they're all summed up. So this is British Columbia, that's Vancouver Island, Strait of Juan de Fuca, South Puget Sound, and Willapa Bay. So these are all fish that we put tags in to track them, and then we took scales. And we're essentially asking, how old are you to these fish? And each color represents that age, and it's kind of summarized here. But the main point is cutthroat trout that we catch and handle, and maybe the ones you all do, are 2, 3, 4, and 5 years old. And no matter where we go, we see those sort of like 2, 3, 4, and 5 in the marine environment. That's what we're catching. But then if you look over here at this vertical axis, this is where the scale reader goes kind of nerdy and tries to understand exactly what each fish was doing. And we don't have time to dig into all these different things, but these are essentially the choices that cutthroat trout can make in their life. And so the way this first one works, if you're having trouble seeing it, this says 1.f plus, and everything before the dot represents when it was in freshwater. So this first fish was in freshwater for 1 year, and then it went to sea. And then this F represents it coming back into freshwater, not spawning and going to sea again. So this is a 2-year-old that spent 1 year in freshwater. If you go all the way to the top, this fish has a 3 before the dot. So that fish went to sea at age 3. But it has 2 S's. Freshwater, it spawned twice. So this is went to marine water in 3, came back and spawned as a 4-year-old, came back and spawned as a 5-year-old, then we caught you in the marine environment after spawning twice. So you can see if you kind of cruise down this list, I mean, there's like all kinds of options. And this is 200 fish, not that many that we sampled. So if you started adding more fish, you would see more options, maybe even older fish. But the summary here is among 200 fish, we had 20 unique life histories. It's pretty crazy. And a maximum age of 5, which is a deeper conversation we should probably have at some other time. That age 5 is pretty young for a cutthroat trout. And if there was someone in the room that caught one in the 60s and had the same information, it would probably show us some 8, 9, and 10-year-olds. And again, it's sort of like a teaser because that's a fun conversation we should have another day. But this is what we're seeing modern time is age 5 is about maximum age. So we showed scale data. It's kind of like hard to imagine this is like kind of indirect assessment of life history diversity. And so when we tag a fish, we get to track where it goes in the environment. We've spent some time with a snorkel mask, started cheating. Like we know there's a few fish in this pool. We know who you are. We know how old you are. And we want to see what the heck you're doing. So we'll put our head in the pool here. Oops. And often, let's see, videos are always a little sketchy, but we're going to try it anyway. So what we're looking at here, this is a female. It's about an 18.5-inch cutthroat, and then 2 really large males behind her. And they all have tags. We've been tracking them, and they're headed up to the spawning grounds. This is in the spring. And so we kind of know what's happening. If you know salmon, these 2 males are going to duke it out. But then we often see this, like a little small male, right? Again, we're pretty familiar with the sneaker male thing. With cutthroat trout, though, it's a little bit unique because these sneaker males have never gone to sea. And so we've often wondered, like, what is this guy's role? Like, how is this going to work out for him with 2 17-inch males and 1 big female? And this question, like, kept me up at night because there's really not a great way to understand, like, what the heck is that little one going to do? And we like fully figured out how to understand that little guy. And the opportunity came to us when Fish and Wildlife Enforcement started recovering poached cutthroat trout in a number of marine environments here. This is, looks like my laser. This is South Puget Sound again. These red dots show places where either poachers killed cutthroat trout and got caught, or we found carcasses, or we're fishing and we see a heron get one and we chase down the heron and like it ditches the fish. And the reason we were like stealing food from herons is because we really wanted this otolith. This is the ear bone. All bony fish have it. Ear bone's kind of a crude way of describing it, but this otolith can describe age and life history, like we talked about with the scale. But it's also like a seashell where it puts on sort of new material as it grows through life. You can go day by day and count how many days this fish has been alive. And then this is built based on elements in its environment. So it's building it based on where it lives. So we can understand a lot about this. And this is, again, a longer discussion, but I really want to show, I thought this was worth showing to this group. We can take these otoliths, we can shoot a laser across the surface. There's like otolith microchemistry. This laser shoots up dust on the otolith and sucks it up, and then it analyzes that dust for the chemistry. So there's like much smarter people than me doing this work. Of course, it's pretty complicated, but the way it works is pretty simple. It moves across this line and it builds us a chart like this as it moves across. And what we know is in the marine environment, there's a whole bunch of strontium. So cutthroat trout in the marine environment, when you catch them and kill them, or a heron kills them and you steal it, the strontium on the edge of the otolith, both edges here, I'll click this because I think I have a little guide, is really high. And so this tells us that this fish was caught in the marine environment. We already knew that, but it just shows us that it works. You can then go to the core of the otolith and ask the question, is the strontium high? And what we know is that cutthroat mothers, when they're at sea, just like steelhead and chinook and coho, they're building their eggs. And in the eggs, they're putting yolk. And when the baby's born, it eats the yolk. And so it's picking up its mom's nutrients. And that's how the baby builds its otolith. So that's the very, very center of the otolith. And this is the mother's strontium that's been placed in the otolith. So what this is here is it's an anadromous cutthroat, we can see because of the strontium, that had an anadromous mother. And that's not like big science. Searun cutthroat make searun cutthroat. That's pretty cool. But we were really interested in like resident mothers that have never been to sea. Are they making cutthroat trout, searun cutthroat? So when we run about 50 of these dead cutthroat, we start seeing a bunch of these. So this is a searun cutthroat. You can see by the edge of the strontium. This is sort of failing, but out here. And then you see this flat line in the middle. So this is like a fish that made babies that had never been to sea. When you add up all of these big ones that are produced by these little ones, you get 32% of our anadromous cutthroat were produced by resident mothers. So if you're like into local habitat or what that little cutthroat is above a falls or on a golf course stream, like a ditch, we know these are extremely important to our anadromous cutthroat. Like about a third of them are produced. And these are mothers. These are not sneaker males, right? These are all small-bodied, tiny fish making small eggs, producing, big ones. So, and it's South Puget Sound. If anyone's been down there, these aren't huge systems. These are tiny little streams producing massive amounts of anadromous cutthroat. So this was a big one for us in understanding, how these freshwater patterns really matter for the marine. So I'm going to just pause because that was kind of a lot. Is there any like major questions or should we just kick them to the end? Yeah.
Talk about was in Congress also for cutthroat, that question about why does the steelhead go to sea, versus other rainbows? Would that perhaps, and I know we're supposed to be talking about cutthroat, but exactly, but that perhaps tell us a little bit more about why some of these rainbows become, steelhead?
Yeah, a lot of the cutthroat work we're doing now, we're stealing pages out of the Steelhead Science Playbook, for sure. And I think when we're like sort of looking at these puzzles, we're like 32%. Like, is that really right? You can start understanding what Nykiss, rainbows, and steelhead are doing. And you see, yeah, this is right. Historically, when habitat was different than it is now, and our systems were more productive, both marine and freshwater, we know that even in small systems, like you can think about the Kitsap Peninsula, the Whidbey Basin. These were probably had rainbow trout resident forms producing massive numbers of steelhead. That was probably important. And in some cases, they still are. Skagit's a great example of that. Yeah. So marine movements has kind of been the holy grail, especially if you're an angler and you're out there catching them, and it feels like, today I caught 10 and I come back same tide, same place, and I caught 0. So this has been a big one, but the Coastal Cutthroat Coalition in the beginning operated on about a $500 budget. So all these experiments were like super low budget. And so we were kind of working like, late in the night, like, how do we understand how these fish move? And we had like a really cool opportunity show up with that limited budget, using beach seine. So in South Puget Sound, there's a lot of folks using beach seine for forage fish. And we had a biologist at Fish and Wildlife come in one day and say, "Hey, James, I heard you like care about cutthroat. I am like studying smell and I just caught 75 cutthroat in my beach seine." And I'm like, lock up the office as quick as I can and like spread out to this beach. I don't believe it. I'm assuming this is like forage fish biologist, caught a bunch of stickleback, and they like got them confused. So we went out the next day to the same beach, same biologist, same beach seine. And so this is this bar right here showing the number of cutthroat caught in January. And we caught 47, I think. I'll show you exactly how many in one tow of this beach seine in a space a little smaller than this room. And it's at a popular beach, like particularly myself, I fish and maybe catch 1 or 2 a day. And so now I'm seeing like, okay, wow, we caught a bunch of fish that day. And so we did in January what any like great fish biologist would do. And they just like catch all these wild fish. They don't have to just say like shove a tag in them. It's like sort of the standard. But we didn't have a bunch of expensive tags. So we used this elastomer tag. It's this little plastic rubber band. It's like almost free. And you can inject it on the skin. With salmon, we put it behind the eye. But cutthroat are so colored up that we thought maybe the jaw would be good. So here we were like, put it in there, no big study idea, no question. We're just like tagged all of those 46 fish or whatever, and then released them and high-fived. I was like losing my mind. Like I'd never seen so many wild searun cutthroat. And then I'm like telling Phil, the forage fish guy, like, we're coming back next month and we're doing this again for sure. And so we did that every month of the year for 1 year at the same beach, same net, same tide, because we didn't know anything more about it. We're like, let's just do it here. And you can see these numbers are jumping around. I mean, almost 100 wild searun cutthroat in one tow. I mean, it is like incredible to see. But each time we put a different color in the jaw of these fish. And what we noticed is like in February, we came back and we immediately noticed like we were getting fish with that original color and getting recaptures. So not only were we catching, 100 cutthroat, but a lot of them were recaps. And that was like a total game changer for the way we think about cutthroat, because day one with 40 of them, I've been telling people as a fish manager, like, there's not that many of them out there. And all of a sudden I'm like, shit, there are gonna be thousands of them out here. Like we just got almost 50. And then we showed up in February, caught 100, going crazy, and then you start flipping them over and it's like, oh, maybe like there's not as many as I thought actually. So then, if you put all these numbers up here, these are the real numbers. 45, 97, 83, and then this is the recapture. So day one or February, we had 15% of those 97 had tags. And by the time we got to April, we only got 28, but every single one of them was one we had handled previously. Like every one of them. So we couldn't find one without a tag in it. So we knew instantly that these fish have like super high site fidelity for their beach. Either they stay there and never leave, or they're coming and going. We like to think of it sort of like orcas, on San Juan Island, like they're coming back to these spots over and over that they like. But then this thing really like sort of the top got blown off it when we started looking at the data and understanding when they had these different tags. So this is a fish we caught in August, and it had 4 of these tags. And so we can look at the data and say, okay, in August or in January, we put orange tags. February, we put yellow. So this fish was at that beach both of those months. Then in March, we used red. And then in April, we used blue. We then seined in May and June. July, didn't catch this fish. But then in August, recaptured it. So if we sort of look at the life of this fish on this beach, we can see that all winter it was probably staging before spawning. It left in May. or maybe it was there, we just didn't catch it, but presumably left in May. And then in the fall, we recaptured it as a kelp. And when you look at the size and the weight of this fish, you can see it growing every single month. And then all of a sudden it comes back in August and it's just super skinny. So just really basic information, but it's like sort of rewriting the way we think about cutthroat at these beaches we fish. And we kind of said all that stuff. And like any great science project, you like leave it with a bunch more questions. And so we knew elastomer tags were great. We used genetics for some other questions about movement, but we decided we really needed to like step up our game. So we talked to the local funders. So these are like folks making beer, donating, $100 at a time. And we're like, we got to step up our game. And we have a really good study here. We want to track cutthroat trout like a real salmon biologist would, and use acoustic telemetry. And so this is an acoustic tag that gets surgically implanted in a fish like this. You can see its little stitches here in its body cavity and it pings. And then this acoustic receiver listens for those individual pings and it records them. And then we can come back a year later and see which fish was where. And it's a proper movement study. And this kind of cartoon of how that would look. And this is how it'll look in Samish Bay. Bunch of buoys, bunch of receivers, and this hopefully a bunch of fish with tags in them. That's the big question mark right now. And so first we tried this out in a beach in South Puget Sound. We tagged 15 of them just to make sure we had the skill set, make sure the fish could handle a big tag. And this hadn't been done for cutthroat trout in the marine water. And so this is an animation. It looks like just a picture because cutthroat don't move much. Took maybe 15 fish to see that, yes, in fact, this site fidelity thing is kind of repeatable. But you'll watch it long enough and you'll see a couple fish shoot off, a couple colors, and then you'll see them come back to that beach. So these 15 fish were like, okay, we think we can handle it. None of them died. All of them sort of lived a life of a cutthroat trout. So we scaled this up. And so the way this looked when we did the real study, when we went big, this is just a year and a half ago, we found partners in Vancouver Island. This is Victoria and Comox. Strait of Juan de Fuca. This is hard to see, but we're looking at like the Dungeness River. And then here's South Puget Sound, and here's Willow Bay. And then the little numbers are how many fish we tagged in each spot. But what's really cool about this, so all these yellow dots, this is the big map, of course, in here. All these yellow dots represent acoustic receivers. So each one of these is like $3,000. And we don't have that much money, of course. So we asked all of our partners that are tagging sharks and salmon and any halibut, and we asked them to use a particular type of tag so that our cutthroat tags could be heard by their receivers. And we promised to do the same with our receivers. So we developed this giant collaboration with all these folks. Some of these projects, we're involved in at Wild Salmon Center, and started tagging cutthroat trout in these areas. And what we saw, this is sort of the results from that work. This is, continental shelf here. Here's where we're at now, or we're like here, over here. All these dots show places where fish were heard by the acoustic receivers, and the size of the dot is the amount. So this is 26 million animal detections. Those 26 million detections represent sharks and sturgeon and like every animal that moved through this environment. But why I'm showing it is because I think it's cool to see how animals are moving. But also you can see these kind of migration corridors. There's movement here, but it's not like off the charts. This is the Fraser River. And then you can see these study areas where we tag cutthroat trout, and they're just like blowing up. So just from that, we're like, man, this might be cutthroat. What's going on? This is a big cutthroat signal. So if you filter it just for our fish, you start seeing that like, yeah, they're really locally oriented. And there's been some great books written about cutthroat, like particularly around the Columbia River plume, going way offshore, or cutthroat swimming to Alaska. We wanted to close the book on that or start to dig into it deeper. And what we're seeing just from this basic information is that these long migrations, they're either totally rare or they're not existent. So for now, we've kind of zeroed in on the place you tagged a fish is probably where it's hanging out. But you can even look at this a little bit tidier and just color code it for where you tag them. And we were kind of interested, like if you tag somebody on this side of the Strait of Juan de Fuca, does it like ever cross? And the answer was no. Like none of our fish sort of moved outside these little areas. And then for each one of these fish, everyone can probably imagine among these bubbles, there's a bunch of individuals. Like they're not going on huge migrations, but they're all doing stuff. And that's where it gets exciting and time consuming, sort of like, you sort of forget about the other things in your life because you're like chasing cutthroat number 13 in its story. And so, two easy ways to look at how all these fish are moving is sort of how far did they go, their total migration distance. And it's sort of like your cumulative clocked miles when you were cruising around in your study area. And then for each fish, you can calculate how big was your area, like what was the circle of space. And that's the home range. And so, so this is sort of summary there. Oh, this is important. Max distance is 39 kilometers. So 40 kilometers. I mean, that's not nothing, but it's not a Chinook salmon for sure. But this is sort of what I was describing. This is the home range here in gray. But within that, I mean, there's lots going on. These are diverse fish. They're doing lots of different things. And this graph, I see it's kind of difficult to see, but the important thing I think is these gray bars. This shows that about 100 fish, stayed within 10 kilometers of where we tagged it. And then as you start moving out here, these gray bars sort of stop at 40 kilometers. 39 kilometers was the biggest home range we saw. That's really important for Samish Bay work, because when we're tagging a fish in Samish Bay, do we need to go all the way up to BC and put receivers? Expectation is no, they're not going to go that far. 40 kilometers is sort of the number that has been sort of sticking. But then these blue bars show the total cumulative distance they traveled. And you can see it goes all the way up to 500 kilometers. And so what that is this number in here. We have some fish that are doing that thing where they just sort of sit there on the beach after you tag them. And as anglers, that's happening. You release a fish, you come back and keep capturing it. You have other fish where their home range is still tight, but they're jumping from beach to beach within their 40 kilometers. So again, this gray is pretty boring. Fish stay close to home. But within home, they're like doing lots of stuff, super diverse. And then the last sort of way to show those data is by area. And this is essentially the same data, but you could ask like our South Sound fish, doing something different. And again, the home range is tight for every one of these, the gray. And then these blue travel distances, like here, Willow Bay, I mean, they just didn't travel far except for these two. These are two individuals that went really far, 37 kilometers or something. So diversity within each area, but a home range is always tight. And I say that with quotes, like, in our experience, the home range is always tight with cutthroat trout. So that's sort of like a snippet of where we've been. When we sort of regroup next time or we're having beers or something, there's lots of other cool little nuances we should chat about, but I think we're all kind of on the same page as the type of work we're doing for cutthroat trout, kind of how we're pulling it off as like a big community here. And then I only have a couple slides for this sort of next part because the Samish Bay project, we're just building it like this group right here. We're going to try to figure out how to pull this off. And so I'm not going to pause just so we'll keep it going, but when it's all done, we can regroup on any of that stuff that was sort of too fast. So this is a bunch of pictures of us doing cutthroat research with the shellfish community. And folks have asked, like, you guys seem to hang out with, Taylor Shellfish or Pacific Shellfish Institute quite a bit. Like, why is it? And if you think about where cutthroat hang out, us as anglers, we know, they overlap with the shellfish industry, like heavily. They hang out in the same environments. And it turns out the shellfish industry, they're pretty cool people to work with. And so when we're like knocking on doors saying like, hey, we saw this buoy, can we tie a receiver to it? Often it's someone in the shellfish industry, and almost 100% of the time they're like, heck yeah, like what are we going to learn? That's been kind of our experience with the shellfish industry. So this is like super cool. This is a local one in South Sound, just a small grower. We need an artist to do a painting of this shellfish farm. But it's much different than like what we would see from like Taylor Shellfish, real large scale. They're helping us with these giant blocks, drop them to the bottom. So a lot of collaboration here. This is a Willow Bay, small grower. And then when we lose receivers, Gordon King does some diving for us. Again, part of the shellfish community. So great collaboration here. But this got pretty formal recently because there's a little box down here in Deep South Sound. It's like around Shelton. Taylor Shellfish wanted to put this really large scale hanging oyster culture setup here where this would sit in front of Shelton and it would grow oysters in the water column, different than what we see on the mud. And they were really interested in how this would affect fish movement in this area. And so we came in before this thing was finished and we tagged a bunch of cutthroat trout because we know when you tag them in an area, that's where they like to hang out. So we thought it was a perfect sentinel for understanding fish movement more broadly. So you can zoom in. This is one of the largest marine receiver sort of networks we put in. But we've zeroed in now. We want to tag them around this shellfish structure. And then we know we've got about a 40-mile range we can sort of zoom in on. That's where the fish are going to hang out. And we want to see how they move around this thing. So if we zoom in one more time, this is sort of the network. And if you're a cutthroat trout and you swim through this thing, you're going to get heard by about 5 receivers at any one time. And that allows us to triangulate within a meter where you were. And that'll happen every 2 minutes. So every cutthroat that's hanging out near this thing, like we're going to know right where you are. So it's pretty cool, focused question. And we're about 1 year into this. And at the risk of like sort of overdoing it on figures, I think this is worth showing. So that's a really big cutthroat. This is the size, this is way too small to see, I can tell now, but this is the size from about 180 millimeters all the way to 400. That's the range of size we tagged fish. And then they're just headed on this line that shows the relationship between length and weight. So you can see how heavy these big ones were. But that's what we're going to target here too in Samish Bay. The tag can hold a fish about 8.5 inches all the way to 20 if somebody catches one of those. But we're going to measure it. So you can't just like say I caught a 20-incher. So we're like going to know exactly how long the fish is. So that's the goal here. Similar to Samish, this is an area we had never really fished. We fished Hammersley Inlet. It's amazing if anyone's down there. Like it's an epic spot for cutthroat. But this beach right here, we haven't really fished. There's another one over here. And so we signed up for this thing and kind of had to grind it out and figure out where the fish were. Once we did, we were like locked in. I mean, we knew the tide and the place and how that all works. So when we started talking about Samish, a guy in Olympia that's been dying to understand cutthroat North Sound, I was like, I think we could pull it off. But I'm just being really upfront about the anxiety a little bit about how do we find a cutthroat in Samish. But we did it in Hammersley. And if we look at the data, this is just a snippet I pulled right before this. These are just a few of the receivers we pulled that were handy. And you can see they're hanging out right where we left them. And then one fish actually came out here. One fish here in freshwater. This is freshwater, freshwater. So we have diversity of things happening, but the hot spot is right where we put the fish with the tag in. The last thing about this slide that I want to share, this on the bottom shows time and the number of total detections. So this is like about 500,000 detections just in like 6 months. And you can see all through the year, all the way to February, we've got heavy detections. Cutthroat are using the marine environment year round. And that's a very South Sound thing that happens. And the fishing is incredible, like right now. So if anybody has time, come on down, we'll fish. But I am thinking, you guys maybe know more than me, that this figure right here will look much different in Samish. It could be that right around November, these fish just disappear and this all goes blank. And then we see them pop out later. There's bigger systems here. Overwintering probably occurs in freshwater more than it does in South Sound. This is what I'm hearing from folks. But we just don't know. So even just a basic, like, when did we hear fish and when did we not, is gonna just like blow the top off of cutthroat trout work. Almost certain it's not gonna look like that. But it'd be cool to be wrong on that. And then I think this is my last slide. So this is Samish Bay. You guys know it way better than me. Just to show that it's different. Here's the box. This question isn't focused like one type of equipment that we want to test how well it's doing for fish. Rather, there's like diversity of shellfish growing. And that's the cool thing. There's lots of different types of shellfish aquaculture, places where there isn't shellfish aquaculture, and how are fish using that differently. And then for folks trying to understand, like, what are we talking about when we say Samish Bay? Specifically, these red dots are the sort of loose idea of where we're going to put acoustic receivers. And this is the area where we're going to try desperately to tag 30 to 50 cutthroat trout in the next 3 or 4 months. So if you catch a cutthroat trout, you have to immediately call me no matter what time of day it is. And I don't need to know the specific spot, but the other people up here that are really good at catching cutthroat, we should tell them. And then everybody zero in and get those tags out together. Um, One thing to note, last thing, is when we did the Shelton project that I just showed with those other maps, place we didn't know how to catch fish, now we do. It's sort of scary as an angler. It's like, okay, do we just publicize this? Now we just unlocked this location. We know how to catch fish. No one seems to have ever caught fish here before. And so we're always devising ways to share the information with everybody, scientists, managers, but also keep the gems like gems, you know? So I just want everyone to kind of think about that. We're not talking about go on Instagram and tell everybody where you caught your fish. But it will take like a sort of group effort to try to get 30 tags out. That's the idea. And then I mentioned there's lots of logos that we should add on as we move forward to this project, but just two right off the bat, or three right off the bat, we should just highlight. That even getting here, you know, to this point, we already have, this is a picture of our first receiver out. I haven't met this person. Someone texted me this, our first receiver. Is the person in the room? That's so awesome. I'm so glad you're here. So this is, do you mind introducing yourself?
Student down at Western United Canada.
Oh, I love it. So this is, I just got this picture from Katie on my phone, just like first receiver out. And this is like what cutthroat science is all about, because you just can't do it alone. And this isn't like a bunch of PhDs like overseeing some project and like trying to make sure it's perfect. It's like, we need to learn about cutthroat and we need to do it now. And so we sent a bunch of receivers up here. We knew there's a bunch of skilled people. Cora's one of them. So thanks for the work. Appreciate it. So we have one receiver out. I think maybe two now, Sylvia? Two receivers out. So yeah, we're moving along. And then in 2 or 3 weeks, we want to get to tagging. So that's what these bullets say. April to October tagging, group effort. And I don't need to summarize all that because I think I said a lot there. So I want to thank you guys for having me up here. This is long overdue and just so much more to talk about. So maybe over a beer too. So.
Very cool. Answer questions.
Yeah.
I'd say, as far as the group effort, I believe coming to the North Sound websites, there'll be a spot where you can report, if you've caught fish in the area. Am I over speaking on that? That's, I feel like, that's getting worked on. So keep an eye on that. So have a way to share information that, you know, where you're catching fish. Yeah. So if there's any questions, so again, we'd like to thank you for coming out. Really great presentation.
Thanks. Yeah, it's fun. Yeah, I'm not in a big hurry. And if anybody too in the room, this is even to this point, it's been really collaborative. So any of the things we sort of nuances that were wrong won't hurt my feelings because we should jump in on the facts.
So you're just getting started up here. Do you have a kind of a ballpark idea about how long this project's going to run?
Yeah, that's great. So Pacific Shellfish Institute applied for a grant through NOAA to understand how fish move around aquaculture. So it's a 2-year study. The tags last 12 months, 16 months. We're going to do 2 years of tagging. So if everything goes well, we'll have at least 30 tags out right now, like in the next couple months, and they'll go for a year and a half almost. And then next year, we're going to be super good at this, like all of us catching trout. So at this time next year, I hope the second batch is also tagged. So it's a 2-year study that the battery life will last 3 years.
But what do you assume is the major river that's the freshwater source that's supporting these Samish fish that you're looking at?
I don't know. One thing that's really attractive, like from, sitting at a desk, like looking at maps, is that it's got lots of these independent streams. And that's been the recipe for us in South Sound. Even areas like if I'm at home on a weekend and I want to just find a new beach, I'll look at kind of the maps and I'll like find places that look a lot like this. But I will say I came in with, on the drive here and saw that low tide and all that mud that everybody had said existed. And I went to undergrad in Bellingham, so I remember it and I was like, yeah, okay. Like, so it's a mystery. for sure. But maybe people in this room.
I mean, the schedule holds, like, I was just pulling up pictures from a past trip, like, we got a bunch in October, you know, south of, or on the seaside of the I-5 bridge, you know, floating that section there. So there's a good amount up in the river up there, but I don't know if those are the fish that are coming up this fall from the skid.
Yeah, great question. Yeah, so the big S rivers definitely produce cutthroat, but is that out of the 40-kilometer zone, or maybe those move further than 40? So yeah.
Up and in the Samish. So when there a bunch of people king fishing down at the mouth when the kings are running, we used to always go upriver, up as far as Thomas Road, and throw flies under the banks and catch them, pretty good sized fish. They would come in at the same time as the kings, and then also farther north, up by Larrabee, we used to actually go snorkeling and watch them along the rocks in June.
Okay.
Up along the cliffs at Larrabee, you put on a snorkel and a wetsuit, and you'd see them schooling along the rocks that far north. So my guess is that probably every one of those little tributaries, whether it's Oyster Creek, Colony Creek, the Samish, and they're going in and out of all of those, because I've seen that whole span at one time or another.
Yeah, very cool.
How many markers? I saw you were looking to put a bunch of markers out in March and April. How many markers do you have to put out? What's the typical mechanism to put them out? Like what's standard for that?
Like the receivers that listen. It's super simple. Like if any of us in the room were like, we want to attach this thing in the water and not have it go away, like be there, you know, in a year, we like, you talk to the shellfish folks, they're super good at putting things in the water and having them stay. And so we're going to zip tie. I should have brought a receiver, and actually in the car, if we're like really going late, I have a bunch of tags and receivers, but, zip tie them to a rope is great. If it's a rope that hangs near a bridge that everybody likes to fish, like that's a bad idea, because people, we all know this. People love to pull things up, cut it loose, and throw it in the bushes. That's like everyone's favorite thing to do, I guess. And so in the reserve, it's great because it's, you know, hard to access in that way. And also at Samish Bay, you start talking to all these great folks in Bellingham that have boats, and there's not a lot of knowledge about